The objective of this video is to determine intervals where a function is increasing, decreasing, or constant. Keep in mind as we go through this particular objective that you always want to read a graph from left to right. So we first define a function to be increasing if f of a is less than f of b if a is less than b. So think about what that means. We're talking about two particular values of x for a and b. If a is less than b, then this means that the y value that corresponds to the a value of x is less than the y value that corresponds to an input of b. So that means as we travel along a graph from left to right, that the graph would have to be rising for that to happen. So if you think about, here's A and here's B, A less than B means A is to the left of B, and f of A has to be less than f of B. So the graph is rising as we go from left to right. A function is decreasing if f of A is greater than f of B if A is less than B. So that means our graph is falling from left to right. Again, a quick illustration here. Let's have a value of A which is less than a value of B. At this time we say that f of A, so that y value has to be larger than the y value at B. So for that to happen, the graph would have to be falling. A function is constant if f of A is equal to f of B for A less than B. So that means that here's A, here's B, their y values have to be the same, so the graph would be horizontal for that to happen. Now when we describe intervals where a function is increasing, decreasing, or constant, we always state these intervals in terms of x, and we use open intervals, which means that we're going to have parentheses on the endpoints of x. So, what we want to do, let's look at these three illustrations that I have here and actually determine the intervals where the function is increasing, decreasing, or constant. So what I suggest is put your finger on the leftmost part of the graph and follow the graph. If you're going up, the function's increasing there. If you're going down, it's decreasing. And if you're going straight across, then it's horizontal. So notice in this parabola, as we go from left to right, I first go up. So that means I'm increasing on this particular piece of the graph. So I've got to tell now what interval that covers. So it's kind of like the domain. We're just talking about pieces of the domain. So that happens to be from what the leftmost point is negative infinity. And where did it stop increasing? At this point, but what is the x value there? That is 0, right? That's the point 0, 4. So it's increasing from negative infinity to 0. And then notice that to continue from left to right on the graph, I'm going down, which means that now I'm decreasing. So we would be decreasing from that x value of 0 for the remaining part of the graph, which goes to infinity. Now, on the next graph, as we begin from left to right, we are going up to some point, and then notice that we come back down, so we're decreasing in the middle, and then lastly we are back up. So we're increasing on two different parts of the graph. So we would say that we're increasing from negative infinity to the x value of this point where it turns. In the next objective I'll show you exactly how to find that. So we'll approximate here, let's say negative 0.2, I'm just approximating. And then where else is it increasing? Well, it starts increasing again between the 1 and the 2, so maybe we'll say 1.6. to infinity. But the key is that it's always the x value. And then we are decreasing between those two intervals, which would be from the negative 0.2 to the 1.6. So maybe you've kind of noticed something. It's really the turning point determines where the function is increasing or decreasing. The turning point is where it changes behavior, and that happened in both of these graphs. Now, the last one, notice that from left to right I am increasing to a point, and then notice what happens. Then what happened? Yeah, it was constant. And then lastly, I was decreasing. So to write those intervals, I'm increasing for x. Where does my x start? At negative 3 to my x value of 1. And then we were constant between my x value of 1 and 4. And then lastly, we were decreasing from my x value of 4 on to the right, which is to infinity. And it might help if you need to, draw an imaginary line through here so that you can kind of pinpoint what value of x those turning points happen to correspond to, and then that would help you identify those intervals that you need. Okay? So if you have any questions, you know what to do. Thanks.